Okay, see we have started discussing about like in which reactions equilibrium is possible. See, we have two types of reaction, reversible and irreversible. Equilibrium possible only in reversible reaction. Give some examples for irreversible reactions. Like acid base reactions are there now. Those are best examples for irreversible reactions. Okay, like neutralization reactions. Next one is what? Precipitate reactions are there. Some reactions leads to formation of precipitate. For example, AgNO3, silver nitrate plus NaCl. What is the product formed? AgCl precipitate will be formed. Okay, so if the precipitate formation is taking place means that reaction is mostly irreversible. Okay, next after this, writing equilibrium constant for a reaction. How to write Kc, equilibrium constant? Product concentrations by reactants concentration. Now, if you are expressing in molar concentration, molar terms like concentration, you know the molarity. Okay, see Kc means what we are writing for a reaction A plus B gives rise to C plus D means what you are writing? Kc, equilibrium constant. It is nothing but, see, for example, what is a forward reaction? Here I am saying forward means A plus B combines to give you C and D. See, now for a forward reaction, rate of forward reaction directly proportional to molar concentration of these reactants A and B. Similarly, rate of forward reaction will be directly proportional to what? See, rate of backward I am saying. Rate of backward means, see, for a backward reaction, it means from here to this side we are moving right now. So, for backward reactions, what are the reactants? C and D. Okay, so you should write here C, concentration of C and D. So, if there is any stoichiometric coefficients like 2, 3 like that, you write here as a powers. Okay, I hope you know this. Okay, and after this, whenever I say equilibrium, a reaction is in equilibrium, how can you write that? Rate of forward is equals to rate of backward. So from this, if I remove this proportionality and placing a constant Kf, and here I am removing this proportionality, writing constant Kb. Okay, so now Rf equals to Rb means what happens here, tell me? Kf into A into B concentration equals to Kb, concentration of C, concentration of D. Can we write it like this? Yeah, can we write it like this? Yeah. So now just bring this Kf and Kb like this. So what happens here? Kf, Kb one side, this concentration on another side. CD by AB, right now? So now these CDs are nothing but product sides we have. Okay, I simply write it as concentration of product by AB or reactant side, concentration of reactant. Just for remembrance purpose, you can make it like this, final one. Okay, now Kf means what? Forward reaction rate constant. What is that?
Forward reaction rate constant.
Kb is what?
Backward reaction rate constant.
Now, the ratio of two constant, forward constant by backward constant, will get a new constant. Something like it is 100, it is 50. 100 by 50. Relation between Kp, Kc. Instead of expressing in concentration terms, molar concentration terms, I can also express in terms of partial pressures. When we use partial pressures, if the reaction is involving gaseous reactants and products. For example, if this is a gas, this is also a gas, okay, and let us say this is a liquid, or let us say liquid, and this is a solid. Now, when we are writing Kp, what to include? Same, Kc lagane Kp kuda rayali. But I am saying in terms of partial pressure. Partial pressure is shown by gases only now. Pressure will be exerted by gas only now. Will it be exerted by liquid here? No. So you should take partial pressure of C multiplied by partial pressure of D. Instead of putting this bracket, I am putting one P. That's it. Okay, and in the denominator, see, let us say, meeku ardham kavadaniki nenu em cheptunnanante, so B is solid, A is gas. Now what I should write? Partial pressure of A, and what about this solid one? Don't write. So the activity or concentration or partial pressure of a solid substance is considered to be 1. If I write here 1, there is nothing change. right now. So you got what I am doing. So whenever a solid is included in the equation, okay, no need of writing in terms of partial pressure and no need of writing in terms of concentrations also. Just put it as 1 activity, we can call it as 1. Okay, this is what law of mass action. Okay, now what is the relation between Kp Kc for a reaction? Kp is equals to Kc into RT power delta Ng. So delta Ng means gaseous products minus gaseous reactants. We did this yesterday. Okay, and after this what we have discussed? Characteristics of equilibrium constant. It means what? If a reaction is multiplied with 2, what happens to its new equilibrium constant? Squared. Okay, if a reaction is multiplied with n, its new equilibrium constant become power n. Let us say I am giving a example because some students are new here again. So A and B are in equilibrium. Okay, so now what I am doing is I am multiplying this equation. See, this is an equilibrium reaction now. So for this equilibrium constant Kc is equals to, let us say, 5. Its value is 5. Now I am multiplying this equation with number 2. It becomes 2A, 2B. That's it now. So its equilibrium constant Kc dash I am writing and I am asking what is the value of it. Okay, so how do you write this? Kc means Kc equals to concentration of product by concentration of reactant. This value equals to 5 we have. Okay, now for this how you will write? Kc dash equals to concentration of B to the power 2, concentration of A to the power 2. Can I write this is B by A all to the power 2. So this is B by A is nothing but this one only, no? So I can I write simply Kc dash equals to 5 square, Kc square or 5 square. Do you got what we are doing here? Everyone clear? Yeah. So instead of taking number 2, if I take a number n randomly, Kc dash equals to Kc to the power n, that's it. Instead of taking n, whatever the number you are taking here, that number is, that becomes power. Okay, up to here clear everyone? Okay, I am erasing this. Okay, just to see now what I am doing. Now what happens, tell me? Kc dash equals to Kc to the power, whatever the number you are taking, take it here on the power, like 1 by 3. Is this clear everyone? Done. So if a equilibrium reaction is reversed, equilibrium constant becomes inversed. Like this it becomes. Yesterday we discussed some questions also on this. Next, if a reaction is taking place in multiple steps, multiplication of all those steps, K final equals to K1 into K2 into K3, so on like that. Okay, done with this discussion? Yeah. So now today we will be discussing a few more things. Yeah, so let us start with this. Okay, before coming to this, see, I have again A plus B giving rise to some product C. Okay, see, during the reaction, it means I have went to the lab and I have started the reaction. So it means at the beginning, at a time t0. So what we have initially, only reactants will be there. Products will not form now before I start the reaction. So at time t0, I have only reactants. Let us say this is of C concentration, or let us say otherwise you take whatever the value you want. Okay, let us say I am taking this is 1 mole of A I am taking, 1 mole of B I am taking, and 0 moles of C will be there at the beginning. Yes or no? Is this clear up to here? Yeah. So after some time what happens? This AB combines and forms C. It means some of these A and B are getting decreased, that are converted into product side. So I can say 1 minus X, here also 1 minus X. So here X represents the quantity of A that is converted into C, product side. So I can say how much amount formed means here X amount. Why X amount? This is what it is consumed now. So that is formed over here. Is this clear up to here? Yeah. Next one, write one more thing. something like this, some random numbers they might be having. See, some reactions having like, if I say ammonia formation, what you will write? 1N2 plus 3H2 gives rise to 2NH3. Like that you are seeing some stoichiometric coefficients right now. In that case, how we will be writing? See, again, at the beginning of the reaction, how many moles of A I am giving you? 1 mole. How many moles of B I am giving you? At the beginning of the reaction, see, this is a balanced equation. You have written that as a balanced equation, let us say. But what I am giving you, you do the reaction by taking 1 mole of A, 1 mole of B. ఈ నెంబర్స్ ఉన్నాయి కదా 1 2 2 అని ఇవి బ్యాలెన్స్ చేస్తే వచ్చే నెంబర్స్ రియాక్షన్ థియరిటికల్గా బ్యాలెన్స్ చేస్తే వచ్చే నెంబర్స్ నేనేమంటున్నా అరే ఈ రియాక్షన్ని మీరు ల్యాబ్లోకి వెళ్ళి చేయండి ఆ రియాక్షన్ చేసేటప్పుడు 1 మోల్ ఆఫ్ ఏ తీసుకోండి 1 మోల్ ఆఫ్ బి తీసుకోండి సో ఐ కెన్ సే 1 మోల్ ఆఫ్ ఏ 1 మోల్ ఆఫ్ బి అండ్ 0 moles ఆఫ్ సి అంతే కదా సో ఆఫ్టర్ సమ్ టైమ్ వాట్ హ్యాపెన్స్ 1 minus some amount is converted now that what is the amount I am saying, let us say x amount. Here you should write 1 minus, you should not write 1 minus x only. What is the stoichiometric coefficient here we have? So 1 minus 2x. And how much amount of product formed means? Here how much it is there? 2x. Here how much it is there? That's why I have written it as 1x. Is this clear or not, everyone? Here how much it is there? So that's why I have written here 1x. Here also 1 now, that's why. Okay, is this clear? Now if I ask you to write equilibrium constant, Kc, what we will be writing here? C to the power 1, A to the power 1, B to the power 1. So what is the C value? X. This one? This one also? B also 1 minus x. So this one x by 1 minus x whole square. Okay, is this clear, everyone? This one you tell me. Kc. 2x. Idi. First, when you are writing at the beginning, try to do it for this equation. C, what is the stoichiometric coefficient? 2. And here A power 1, B power 2. So now you put the substitute these values. 2x square whole square in the 1 minus x, 1 minus 2x. So now you got some different answer. Should not ignore this 2 as a power. Okay, write the equation, then substitute it. Okay, so that you won't get any confusions. Okay, now directly we will do one question on this so that you will feel more clear. Do this. Yesterday at the end of the class I have given this, but I don't know whether you did this or not. Once read the question. Consider the following reaction in a closed vessel. If all the reacting species N2 plus H2 and NH3 are in 1 mole at the beginning. At the beginning itself how much they are saying? 1 mole. N2 is 1 mole, H2 also 1 mole, ammonia also 1 mole. Then next beginning of the reaction and equilibrium is attained. What happened? After some time equilibrium is attained. So when the equilibrium is attained, how much N2 is remained unreacted? 0.7. Using this whatever the data provided, you need to calculate this. Then what will be the value of equilibrium constant? Once you try, if not I will explain. Whatever the steps we followed in the previous slide, follow the same steps. You will get the answer. Okay. Anyone? So how to write this? N2 plus 3H2 gives rise to 2NH3. Okay. Initially what they are saying, at a time t0, at the beginning, time t0, 1 mole of N, 1 mole of H, H2 and 1 mole of ammonia was taken. So after some time what happened? Equilibrium is attained. It means equilibrium is attained. After that equilibrium is attained, N2 remained unreacted is how much? 0.7. It means what I told you at time t equilibrium, like some amount is converted now. How can you write that? 1 minus x. This one how to write? 1 minus 3x. Is this clear everyone? 1 minus 3x. This one? 1 is there. Previously it is 0. 0 plus x we have written, that is x only. But here 1 plus 2x. Is this clear everyone? Okay. So now see 1 minus x is nothing but ఇంతకు ముందు ఎంత ఉందమ్మా? ఫస్ట్ ఇనిషియల్గా 1 ఉంది. 1లో నుంచి కొంచెం తీసేసినామంట. అంటే 1లో నుంచి కొంచెం అంటే x అమౌంట్ ఇట్ కన్వర్ట్ అయింది. ఇంకెంత రిమైనింగ్ మిగిలింది? అంటే 1 minus x equals to 0.7. So now x will be equals to 1 minus 0.7, that is 0.3. Everyone clear or not? Yeah. So you got x value. So with the using of this x value, you can get the concentration of this H2 at the equilibrium. 1 minus 3 into 0.3. So 0.9, 1 minus 0.9 will be this one 1 plus 2 into this is 0.6 plus 1 point. Clear up to here everyone? Yeah. అర్థం కాలే? ఓకే, నేను మళ్ళీ దాన్నే రిపీట్ చేస్తా. ఇట్లా రాయడం అర్థమైందా? ఆ డేటా ఏమి ఇస్తే అది రాయండి. నెక్స్ట్ స్టెప్లో ఆఫ్టర్ సమ్ టైమ్ ఈక్విలిబ్రియం ఈజ్ అటైన్డ్. ఈక్విలిబ్రియం అటైన్డ్ అంటే ఏంటి? సమ్ అమౌంట్ ఆఫ్ రియాక్టెంట్స్ ఆర్ కన్వర్టెడ్ ఇంటూ products. How much amount? We don't know now. That is 1 minus x you can write. Here 1 minus 3x. Why? Because coefficient is 3. Here 1 plus, because product is formed. Reactants are consumed, product is formed. That's why here plus. Up to here it is clear. 1 minus x is how much they are saying? Remain unreacted means that is leftover. N2. So ante enta react ainattu 1 lo nunchi 0.3. ఇది లెఫ్ట్ ఓవర్. ఇంకా రిమైనింగ్ ఎంత ఉన్నట్టు? 0.3. ఓకే, సో ఎక్స్ వాల్యూ ఈజ్ అమౌంట్ రియాక్టెడ్. సో ఇఫ్ యూ పుట్ హియర్ ఎక్స్ వాల్యూ, యూ విల్ గెట్ హౌ మచ్ అమౌంట్ ఆఫ్ H2 ఈజ్ లెఫ్ట్ ఓవర్. అండ్ దిస్ వన్ ఆల్సో హౌ మచ్ అమౌంట్ ఆఫ్ ప్రోడక్ట్ ఈజ్ ఫార్మ్డ్. 1 ప్లస్ 2 ఇంటూ 0.3 అంటే ఇంత వచ్చింది. ఓకే, ఇప్పుడు కేసీ వాల్యూ ఎట్లా రాస్తుంది? బై 0.1 తీసుకోవాలి, 0.7. What is the concentration of N2 remaining ma? ఇప్పుడు ఇక్కడ ఏ వాల్యూ తీసుకుంటున్నాం? 0.1. Why 0.1 we are taking? That is the amount of H2 remaining now. So here if you are taking 0.1 whole cube, what is the value remaining after reaction? 0.7 to the power 1. ఇప్పుడు 1 ప్లస్ 2x వాల్యూయే కదమ్మా మీరు తీసుకునేది. 1 ప్లస్ 2x వాల్యూ ఎంత? అది ఇక్కడ తీసుకున్నప్పుడు మరి ఇక్కడ ఏం తీసుకోవాలి? 1 మైనస్ ఎక్స్ వాల్యూయే కదా మీరు తీసుకోవాల్సింది. 1 మైనస్ ఎక్స్ వాల్యూ ఎంత అన్నాడు? లైక్ దట్ ఐ షుడ్ టేక్. ఇక్కడ 1 మైనస్ 3x వాల్యూ ఎంత? 0.1. అదే ఇక్కడ తీసుకున్నాం. ఓకే, జస్ట్ సింప్లిఫై దిస్. సి హౌ కెన్ ఐ రైట్? 1.6 means 16 into 10 power minus 1 to the power 2. So this is simply I can write 16 square 10 power minus 2. Okay, denominator 7 into 10 power minus 1 into this is 10 power minus 3. Can we write it like this? Okay, so how many times? 10 power minus 2 is remaining here. 16 square means 256 by 7. కింద ఎంత ఉంది? ఇంకా 10 power minus 2. So can I write this in the numerator? How can you write this? 10 power 2. Try to simplify this. This will be 3s are 21. 21 means 4 is there. 6 are 42. 4 is there. 5s are 7s. So we have some value over here. 3, 6. I mean here point is there. So 3, 6, 5, 7. Some number here we have option 2. Is this clear or not, everyone? Simplification అంత అర్థమైందా? ఇంకేమైనా కన్ఫ్యూజన్స్ ఉన్నాయా? ఓకే. మళ్ళీ ఒకసారి చూడండి. వాట్ ఈస్ ద కాన్సన్ట్రేషన్ ఆఫ్ అమోనియా? 1 + 2x. 1 + 2x అంటే x వాల్యూ ఎంతమ్మా? 0.3. ఇక్కడ పెడితే మనకు ఫైనల్గా ఎంత వచ్చింది? 1.6. సబ్స్టిట్యూట్ ఓవర్ హియర్. నెక్స్ట్ ఇక్కడ 1 - 3x అన్నాం కదా. సో x వాల్యూ అగైన్ యూ పుట్ హియర్, యూ విల్ గెట్ ద వాల్యూ ఆఫ్ H2 కాన్సన్ట్రేషన్, దట్ ఈస్ 0.1 to the power 3. సేమ్ హియర్ ఆల్సో 1 - x value is how much? Put here directly, you will get the answer. That's it. Okay. Next. Okay. See, sometimes we use the word degree of dissociation. What is the word we are using? Degree of dissociation. It means amount of a particular substance getting dissociated is given by degree of dissociation. So what do we mean by degree of dissociation here is the number of moles dissociated, total number of moles taken, or initial number of moles, See, for example, PCl5 will getting dissociated as PCl3 plus Cl2. Okay, initially I am saying 5 moles. Suppose 5 moles of PCl5 is taken. Okay, now how many moles it is dissociating? Taken, and if 2 moles are getting dissociated out of 5, like 1 minus x we have written now previously, here 5 minus 2, 5 minus 2, because 2 moles is dissociated. How it is dissociating? PCl3 plus initially, when I say initial, it will be 5, this is 0, this is also 0. Out of 5, how many moles dissociating? 5 minus 2. So that same 2 will be forming as PCl3 and here you should write 2 and 2. Okay. So now if I ask what is the degree of dissociation, how many moles we have taken initially? 5. Initial number of moles in the denominator. How many moles dissociated? 2. So 2 by 5 you can write. So 2 by 5 means how much it is? 0.4. So degree of dissociation for this substance is how much now? 0.4. Like this, we can calculate the degree of dissociation. Okay, next one. Here, see, if I say A and B are in equilibrium, I should write like this. I can also write this in this format. So what is this indication? Reaction is more favoring towards which side? Backward. See, one which is bigger one, that side reaction is moving. One more way I can represent like this. Reaction is favoring more towards forward. See, at this condition, what is this? It is an equilibrium reaction. 1 and 3, are they equilibrium? These are not equilibrium reactions. Up to here it is clear. Now, at this equilibrium state, if I write Kc, how do you write the Kc? Concentration of B by concentration of A. Okay, now what is this Kc called? Equilibrium constant. Okay, so you should say the ratio of concentration of product to concentration of reactant as equilibrium constant only at this state. If I write same thing here, B by A, I should not call this as Kc. I should not call this as Kc. I should call it as Qc. What is that? So Qc is called reaction quotient. What is this? Reaction quotient. Okay, so here also I should not call it as Kc. What I should call? Reaction quotient Qc. So it is also Qc, which is equals to B by A. Okay. So now if I say Kc is equals to Qc, what does it mean? Reaction is attained equilibrium. If Kc, Qc are not equal, reaction is not attained. Okay. So now you need to know, in a chemical reaction, the most stable state is equilibrium state. What I am saying, in a chemical reaction, the most stable state is equilibrium. See, you are also observing in our daily life also. See, for example, you have two containers. One container is having more water and one is having less water. So the process of flowing of water takes place until they reach equal quantities. It means until they reach equilibrium condition. Once after attaining equilibrium, you are seeing a steady state. There is no movement or there is no further flow right now. So it means in the nature also, what is the most stable state? Equilibrium state. So during a chemical reaction, what is the most stable state I am saying? Equilibrium. So here in order to attain this equilibrium condition, see, in order to attain this equilibrium condition in this reaction, so equilibrium should move which side, they will ask. Okay, I will tell you. Once again, listen here. Qc equals to Kc. What is this state called? Equilibrium state. One more state I am writing. Qc is less than Kc, or Qc can be greater than Kc. Like these are the possible ways. So when Qc is less than Kc, what is less here? Qc. So in order to make them equal, what I should do? What I should increase? Qc value. So in order to increase Qc value, which side reaction should go? Product side. So whenever Qc is less, this favors forward reaction. What it favors?
Forward reaction.
Do you got what I am saying? Okay. So if Qc only greater? Backward. But you understand, now you will say backward. But why it is backward? See, in order to make them equal, this value should be decreased. It means concentration of C should be increased. Concentration of C, see, this is decreasing now, this should be increased, this should be decreased. It means which side this equilibrium should move? Backward. So if this is the case, backward reaction is favored. So if Qc equals to Kc means? If Qc is less than Kc, Qc greater than Kc, that's it. So this is about the thing. Now most of the equilibrium reactions, Kc value lies between 10 power 3 to 10 power minus 3. So what are the values you are saying? For a equilibrium reaction or reversible reaction, this Kc value lies between what? 10 power 3, 10 power minus 3. So lowest value is? Highest value is? Okay. So now what if the value is greater than this? It means if value is greater than this means reaction is more favoring towards forward only. If value is less than this means reaction is more favoring towards backward. That's it. Okay. So for equilibrium reaction, Kc values lies between minus 3 to 10 power plus 3. Okay. Write this. See, you just summarize this in your notes and this value. Done? Over? Fast. if Kc equals to Qc, equilibrium. Qc is less than Kc, ఇగో ఇది తక్కువ ఉంది కదా, దీన్ని ఈక్వల్ చేయడానికి మూవ్ చేయాలి. అప్పుడు ఏమవ్వాలి, రియాక్షన్ అనేది ఫార్వర్డ్. ఓకే, సో ఇఫ్ QC is less than Kc, reaction moves forward. QC less than Kc, backward. That's it. Okay, next one, before starting the discussion of Lee-Chatelier principle, just try this question fast. When 1 mole of A and 1 mole of B were heated in 1 liter flask, 0.5 moles of C is formed at the equilibrium. What is the equilibrium constant they are asking? Very easy. How to do this, tell me? Initially what they have? 1 mole of what? A, B. Do they have anything C and D? No. So it will be 0, 0. After some time t, what should I write? 1 minus x, 1 minus x. This is 0 plus x, 0 plus x. Next, 1 minus x value, how much they are saying? Like see, x 0.5 is, C is present. It means x is equals to 0.5. And then put in that and you will get the answer. Do it fast. See ma, if this is x, this is also x. At equilibrium, what they are saying, 0.5 moles of C is formed. It means this is also 0.5. Once try everyone. What is the answer? 1 is perfect. Very simple only, na? See, how much of A we have? B at initial. This is 0, 0. After some time t, x and x. That's it now. So what is this value of x they given? 0.5. If this is 0.5, this is also 0.5. Clear? 1 minus x. This is also CD is 0.5, like Kc equals to, this is 0.5, this is also 0.5. Here these two things also. So everything is same, means easy only. What I am discussing what equilibrium reactions. Now let us say A and B are in equilibrium. A, B are in equilibrium. So now what we are doing, see, equilibrium is the most stable state I am saying now. What is that? Equilibrium is? So most stable state. Now if you disturb anything at the reactant side, if you are doing, see, for example, there is 2 bowls having equal quantity of water with one connection. Now you are trying to increase water in another one container. What happens? That water will flow to the another container and they will attain same level of water and they will remain undisturbed again. Again you are wantedly adding. Again it will move forward. Yes or no? Now this time here you are adding. It will move the back one, back reaction. Like that, same thing applicable here also. See, this is an equilibrium reaction. You are disturbing the equilibrium by applying some stress on X, stress on this A. What happens? The equilibrium will move towards B side. Or you are applying some stress here. So it means why that movement is taking place? To reattain its equilibrium state once again. Now once read this, it states that if a stress is applied on the equilibrium system, then the equilibrium for the time being get disturbed. You are applying some stress, therefore equilibrium will get disturbed. Okay? So as a result, system moves in a direction to nullify that stress. ఇప్పుడు మీరు ఏమైతే stress, nullify means what? To cancel out that stress. Okay? So to nullify that stress or to relieve that external stress. It means what do we mean by nullify here? మీరు ఇక్కడ స్ట్రెస్ అప్లై చేశారు అనుకోండి, అగైన్ ఇట్ వాంటెడ్ టు రిఅటైన్ ఇట్స్ Equilibrium. Okay, let us say I am increasing the concentration of A. What happens to the equilibrium? See, this is at the equilibrium reaction ma. So what I am doing is stress I am using now. So that stress is nothing but it can be concentration, it can be pressure, like that. So what I am doing, I am increasing the concentration of A. Equilibrium moves forward. Okay. Now otherwise I am decreasing the concentration of A. Backward. Why? Because see, its concentration is decreasing now. So to nullify that, some amount of B is converted into A. Okay. Otherwise I am increasing the concentration of B. I am increasing the concentration of B backward, or I am decreasing the concentration of B. This is clear? Okay. Now I am doing a reaction. What I am doing? Reaction. So it is a reversible reaction. But I want product formation more. What I should do? Whatever the product is forming, I should remove it out so that equilibrium moves forward. So like that we can improve the production of that particular product. Okay, this is about the effect of concentration. So what is the effect of concentration? Increase in the concentration of reactants favors forward. Decrease in the concentration of reactants. Decrease in the concentration of product. Decrease in the concentration of products. Forward. Decrease in the concentration of product. Decrease in the concentration of product. Forward. Increase in the concentration of products. Okay. This is about the effect of concentration. Next one is about temperature. See, it is very easy for temperature. See, during the reaction they will mention like this. Delta H is negative. Some negative value they will mention. It means this negative indicates it is an exothermic reaction. What is that? Exothermic reaction. See, heat is releasing from the system means what happens to that system? Its energy, like temperature decreases or increases? This is that system in which reaction is taking place. It is releasing heat. It means negative I should indicate. It is releasing heat means its temperature what happens? Decreases. So for an exothermic reaction, forward reaction, temperature decreases now. It means forward reaction taking place by lowering its temperature. By what? By lowering its temperature. So I can say whenever there is an exothermic reaction, low temperature favors forward direction. What I am saying, low temperature favors forward direction. If delta H is positive, positive means what? Reaction is happening by absorbing the heat. So it means you are adding the heat to the reaction. So when delta H is positive, what you should say? Opposite of that, high temperature favors forward reactions. So exothermic forward reaction favored by endothermic, forward reactions are favored by high temperature. See, for a particular reaction, if forward reaction is exothermic, then backward reaction is endothermic. Once again, for an equilibrium reaction, forward reaction is exothermic, then backward reaction is endothermic. It means, for example, forward reaction is exothermic, then its temperature is low temperature favors forward. If I use high temperatures, goes backward because backward is endothermic. Are you getting what I am saying? Yeah, use these two things again we will discuss during the questions. Okay. Next one, listen this very clearly. Effect of pressure. What is that next one? Effect of pressure. Please listen here, otherwise it won't be clear to you. A plus B, C plus D. Let us say all of these are gases only. What I am saying? See, effect of pressure will be valid only in case of gases. Effect of pressure is seen only in case of gases. See, gases, whenever they have given gases, so just to find a delta Ng. What is a delta Ng here? Gaseous products minus gaseous reactants. 1, 1, 1, 1, 1. Okay, so it means 0. If it is 0, no effect of pressure. What I am saying? No effect. It means you can increase the pressure, no effect. You can decrease the pressure, no effect on the equilibrium. But what if these coefficients are not same? For example, you are doing a reaction like N2 plus 3H2 gives rise to 2NH3. You are a scientist now, you are doing this reaction. Okay, now you want to produce what? Ammonia. What you want to produce? Ammonia. Now they will ask you, what are the favorable conditions to produce ammonia? You need to check its temperatures, you need to check its concentrations, you need to check its pressures, all these conditions, no? That is what you are doing here. Okay, we'll come back to this later. First you study here. See, instead of this, I am taking, now find delta Ng. Delta Ng, 2 plus 2, 4. Delta Ng is greater than 0. It is greater than 0 now. Okay, so when delta Ng is greater than 0, so just look what I am doing. Not this. Okay, how many gaseous reactants are there? 2. How many gaseous products are there? 4. Now consider this is happening in a beaker like this, in a container, closed container. Now you are applying pressure, ma. So high pressure, what happens if you apply pressure on this container? That will its volume compressed. It means in unit value previously we have only 2. Let us say they are becoming double. Okay, so munde enni unnai mana daggara? Let us say this is doubling. It means how much I should write? 4. Here also it is doubling. 8. So where do you see more number of increments? See, this side only 2 times increased, and means 2 to 4 means 2 times. From here to here? 4. So where the more increment is observed? Product side. So if you increase the pressure, the effect will be more on more number of side. More number of moles side. Where do we have more number of moles? Product side. Okay, then here increment is more now, equilibrium goes opposite direction. So in the simple words I will tell you, here you just remember effect of pressure now, equilibrium shifts in lower number of moles side upon increasing pressure. What I am saying, equilibrium shifts in lower number of side upon increasing pressure. So where do we have more number of moles? Product side. If you increase the pressure, which side it will move? Read this statement once again. Equilibrium shifts in lower number of moles side upon increasing pressure. So where do we have more number of moles? Product side more number of moles, no? Then equilibrium should move reactant side. So delta Ng is greater than 0 means you should say high pressure favors backward reaction or backward side. Okay, then if I want to move forward, which pressures I should maintain? Low pressure favors forward reaction. Okay, see ఇది అంతా మాకు గుర్తుండదు సార్ అనుకున్నారు అనుకోండి, జస్ట్ రిమెంబర్ దిస్. డెల్టా Ng ఇదంతా మాకు వద్దు అనుకున్నారు అనుకోండి, జస్ట్ ఫైండ్ where do we have more number of moles? Gaseous moles, product side. So if I increase the pressure, what happens? Lesser number of moles side it will go. Where do we have less number of moles? So if we calculate చేయండి, 2 plus 2 4 gaseous products ఉన్నాయి, 2 gaseous reactants ఉన్నాయి. So if I increase the pressure, అప్పుడు lower number of moles side equilibrium అనేది మూవ్ అవుతుంది గుర్తుపెట్టుకోండి అంతే. Okay, next. See, this is one story. Next, similarly delta Ng is less than 0 అయింది అనుకోండి, opposite of this. High pressure favors forward reaction, low pressure favors backward reaction. Okay, that's it. Let's solve some questions. Done? Okay, look at this question. Which are the following conditions will favor maximum formation of product? First, temperature you check. What is this? Exothermic. So, forward reaction favored by low temperature. Low temperature. Next, pressure you check. How many gaseous products are reactants are there? 1 and 1. So 2. This side 1. So where do we have more number of moles? So if I increase the pressure, what happens? That's it. So high pressures, low temperatures, high pressure. That's it. This is the perfect one. Is this clear, everyone? How to answer? Negative means low temperature. Okay, and high pressures or low pressures ela teliyali? Itla number of moles check cheyandi. Where do we have more number of moles? This side. So if I increase the pressure, moves forward. Okay, that's it. Next. Do this fast. Observe the following. Desna and So what happens if I increase the concentration of H2? Concentration of reactant increased. ఏమవుతుంది reactant concentration increase చేస్తే? Forward. So it will be disturbed by adding H2. Removal of HI. If I remove this, what happens? Decrease the concentration of product. ఇది తీస్తే ఏమవుతుందమ్మా? Forward. Okay. Addition of I2. You are increasing the concentration of reactants. Forward. Okay. Addition of He. He means what? Helium. So this is called effect of inert gas. What is this? Helium is inert gas now. So will this inert gas react here? That won't react. Just increase the volumes here. See, find delta Ng here. What is the delta Ng? 2 minus 2, 0. If delta Ng is 0, there is no effect of pressure we know now. Similarly, no effect of volume also. It means no effect of inert gas also. If you add any inert gas, there will not be any effect. Okay, so which is our perfect answer? Addition of helium. Tell me for this fast. Favorable conditions for forward reaction. See whether it is exothermic or endothermic. See, along with our product, heat is also released. See, the same reaction, look at here, indication of chemical reactions. A plus B gives rise, A is giving rise to B means our product is B, right? So they may say like this, delta H is negative, like this they may say. It means this is exothermic. The same reaction may be indicated like this, B plus some delta H. It means plus some X kilojoules of energy is released. See, along with our product, X amount of energy is released. So X is now released only now. So it can be indicated like this, or separately it can be written like this. Both indicates what? Exothermic only. So endothermic means they may say delta H is positive, they will say. Otherwise, they will write here. Along with these reactants, they have added some X kilojoules of energy. So this is also indication of what? Endothermic. Okay, now tell me what is your answer for this? Low temperatures, low temperature, because it is an exothermic. Next, pressures. See, here number of gaseous reactants are 3 by 2. 1 plus 1 by 2 means 3 by 2. Gaseous products are 1. Where do we have more? So high pressures favors less number of moles side, this side, forward. So they are also asking us forward. So high pressures, low temperature, B. Is this clear or not? Yeah. Answer me this. Simple, simple. See, it should be B only. Why? Because all of them are solids. Okay, it should not be any effect on solids here. Next is simple one. Answer me this. Only A. Why A? Here it is 0, 0. Okay. Next one. There is one question. Read this question. Okay, addition of aqueous oxalic acid solution to the above equilibrium. What happens? See, oxalic acid, if you add, that forms complex with this iron plus 3. It means what happening to the iron plus 3 concentration? Oxalic acid మీరు యాడ్ చేసాం అనుకోండి, అది ఏం చేస్తుంది, దీంతో రియాక్ట్ అవుతుంది. So all the Fe plus 3 ions are taken by oxalic acid. Now what happens to the concentration of Fe plus 3? Decreases. If its concentration is decreasing, equilibrium shift backward. So now tell me, if it is shifting backward, what happens to the colors? Like go through the option, shift the equilibrium towards formation of product? No. Deep red color increases. It means deep red color increase kavalante adi etu move avali, but it is moving backward now. Deep red color intensity, so intensity of deep red color decreases. So option C, and there is no change in equilibrium. No, only option C is perfect. Clear? Yeah. Again, this is done. You can do all these questions. It's fine. You can able to do those. Okay. Now, during a reaction, if temperature is changed, what I am saying, if temperature is changed, it means equilibrium constant is considered to be K1 at temperature T1, and equilibrium reaction constant is K2 at temperature T2. Then what is the relation between K1, K2 and T1, T2, all these things? You just write this one. Log K2 by K1 equals to delta H by 2.303 or 1 by T1 minus 1 by T2. So what this relation gives us? Temperature change, the effect of temperature on equilibrium constants. A, B. Listen this one, once again I am saying, for this equilibrium reaction, equilibrium constant value is 5, let us say. How much? 5. I am increasing the concentration of A. Reaction moves forward, all this happens, we know. But the value of equilibrium constant does not changes. What I am saying? Constant does not change. So this value will be fixed. There will not be any change in concentration, equilibrium constant value. Okay. Now one more statement I am saying, if I change the temperature, what I am changing now? If I change the temperature, then the value of equilibrium constant also changes. That's why at a temperature T1, equilibrium constant value is K1. So if I change the temperature, its equilibrium constant value also changes, that is K2. So finally we are going to get a relation like this. So if I increase the pressure, concentration, volume, is there any change on the value of equilibrium constant? No. But if I change the temperature, yes, value of equilibrium constant changes. Okay, exactly, you will get the relation like this. Okay, done. Okay, so yesterday we have studied something like Gibbs free energy, delta G. So how can you relate that Gibbs free energy and equilibrium constant? See, delta G is written as delta G is equals to delta G naught plus RT ln Q. What I am saying, delta G is equals to delta G naught plus RT ln Q. So if Q is equals to K or QC equals to KC, what is this condition, ma? Equilibrium. So this is at equilibrium. So at equilibrium, the value of delta G is equals to 0. At which state? At equilibrium state 2.303 RT log Kc. Okay, so what is this delta G naught? You can say this as standard Gibbs free energy. This is normal Gibbs free energy at any temperature, but this is at standard Gibbs free energy. Okay, can you convert this and can you tell me what is the equation in terms of Kc? How to write Kc? Kc is equals to, bring this minus this side, minus delta G naught by RT. If ln comes this side, exponential. So this is something like e to the power the thing. Can we write it like this? Yeah. Can you do the same thing for this one? If log comes this side, 10 it will be. Log here. So minus delta G naught by 2.303 RT. Log is there now, log if comes this side, it becomes base 10. So 10 to the power minus delta G naught by 2.303 RT. These are important equations. Okay, see, one direct question is there in the exam. I just wanted to show if it is done. Answer me this. Which is the correct expression? So first one is not correct because at equilibrium K means you should say equilibrium constant. Delta G must be 0. So one is not correct, only C. Next. Yeah. So now we will move for ionic equilibrium. So ionic equilibrium means till now wherever the equilibrium we have seen there is no ions. Here we are discussing about ions. For ions means what? Like acetic acid, if I say, how it will dissociate? Minus and H plus. Okay. See, this is a weak minus and H plus. Okay. See, this is a weak acid now. Okay. So first of all, tell me what do we mean by electrolytes? Substances which allows passage of electricity through them. Okay. So these electrolytes are of two types: strong electrolytes, weak electrolytes. So what are the examples for strong electrolytes? All strong acids all strong bases and all salts. What are the examples for strong electrolytes? Strong acids, strong bases, salts. Give one example for strong acids. HCl, H2SO4, nitric acid, all those. NaOH, KOH, all this comes under strong bases. Next, salts, you give one example. NaCl, and the next, see, sodium acetate. Sodium acetate. Okay, anything like ammonium chloride. All this comes under what? Salts. Salts are also examples for strong electrolytes. Now what about weak electrolytes? All weak acids and weak bases. There is something called sparingly soluble salts. What I am saying? Sparingly soluble salts are simple words, I can say covalent salts. Like you know NaCl, you know, and you know AgCl. So AgCl is considered to be sparingly soluble salt. What do we mean by sparingly soluble salt? మనం NaCl ని వాటర్లో యాడ్ చేసామనుకో ఏమవుతుంది, అది క్విక్గా డిజాల్వ్ అవుతుంది, తొందరగా డిజాల్వ్ అవుతుందిగా. బట్ ఇఫ్ యూ యాడ్ AgCl, సిల్వర్ క్లోరైడ్, ఇట్ వోంట్ డిజాల్వ్ లైక్ దట్. ఓన్లీ స్మాల్ క్వాంటిటీ ఆఫ్ AgCl will get dissolved. That's why I'm saying sparingly soluble. Okay, so what is that example? Sparingly soluble salts, or I can simply say covalent salts. Example, you can write AgCl. These are the examples for weak electrolytes. Okay, so now all weak electrolytes, strong electrolytes are considered to be example like classification of these electrolytes. It means in this and in this. So it will form H. So it will form H plus and Cl minus ions in the water. So instead of representing H plus, I can also represent this as H3O plus. Okay, so H plus ion concentration is raised now. Then I can say this substance as acid. Now those substances which increases the OH minus ion concentration in water are considered to be bases. So this is a concept of Arrhenius acid base theory. Okay, so here you can say NaOH in the water increases the OH minus ion concentration. So I can say this as base. Okay, next one. Listen this carefully. Bronsted-Lewis acid base theory. So what he says is H plus are the proton donor. What I am saying, proton donor is an acid. Substance which donates proton is called acid. Substance which accepts the proton, proton acceptor, is base. Okay, proton acceptor is base, proton donor is an acid. Okay, let us see this one. See what happening here, we have ammonia and we have HCl. Now this HCl is donating a proton and forming NH4 plus Cl minus. See which substance is acid here again? Proton donor. This is the proton donor now. So you should call it as acid. So who is accepting the proton? So this is now base. Now not only this, after understanding this, see this acid after releasing H plus ion, what is the thing formed out of it? Cl minus. So Cl minus come from acid now. That ion should be called as conjugate base. What is this? Conjugate base. Try to understand this EAPCET favorite topic. Once again, acid after releasing H plus, the negative part formed is there now, that is called as base after accepting H plus, positive charge is formed now, that is called conjugate acid. Acid after releasing a proton forms conjugate base. Base after accepting a proton forms conjugate acid. Remember this. Okay. Now tell me, a conjugate acid base pair are differ by what? One proton. See a conjugate like acid and its conjugate base. What makes the difference? One proton. A base and its conjugate acid, how they differ? One proton. That's it. Now I will show you some questions, you just answer me. Answer this fast. Conjugate base of H3O plus ion. What I told you, an acid base, conjugate acid base pair will be differ by one proton. So from this you remove one proton. See, if I say this is an acid, then the proton, after releasing proton, the remaining part is called conjugate base. So H2O will be your answer. Now tell me, what will be the conjugate base of H2O? OH minus. OH minus and H plus. Now tell me, what is the conjugate base of OH minus? What is the conjugate base of OH minus? O. O minus 2 H plus. Is this clear or not? Okay. Now, what is the conjugate acid of H2O? H3O plus. What is the conjugate acid of OH minus? See, when I use the acid, add one proton. When I use conjugate base, remove one proton. That's clear. See, they are asking conjugate base of this. What to do? Remaining part is called H2O conjugate base. So for this, this is the answer. Everyone clear with this concept? Here see once again. What is the conjugate base of chloric acid? Chloric acid means what first of all? HClO 3. What? Arey, conjugate base means what I should do? What after removing proton, what is remaining? Only D. Okay, that's it. Okay, what is the next concept we have? Lewis acid base theory. So what do we mean by Lewis acid? Electron pair donor. Electron pair donor is Lewis acid. If electron pair acceptor, electron pair acceptor is Lewis base. Okay. See, who is donating electron pair here? So this is Lewis base. Who is accepting electron pair? So electron pair acceptor is Lewis acid. This one is electron pair donor, Lewis base. Okay, see, who is donating? Ammonia is donating now. So electron pair donor is Lewis base. Who is accepting? BCl3. So this is Lewis acid. So now tell me here, ammonia is Lewis base because electron pair donor. That's it. So three acid base theories we have studied. First one is Arrhenius. What he says? If you place a substance in the water, it releases H plus ion, then that is acid. If it releases OH minus in the water, base. Next, Brown state, electron pair proton donor, acid, proton acceptor, base. So there only conjugate acid base theory we studied. Next, Lewis acid means electron pair acceptor. Lewis base means donor. Okay, so he told with respect to what? Electron pairs. If electron pair donates, then it is base. Electron pair accepts acid. Fast, tell me for this one last question. We'll move forward then. Fast. HClO4, what it is doing? It is releasing a proton. So if this is an acid, this should be called as conjugate base. Okay, so HClO4 is a conjugate base of ClO4 minus is a conjugate base of. This is correct only now? Correct. Next, this one, H2 is a conjugate. See, it is what conjugate acid base pair differ by? Proton. So base means it should, like, after releasing proton, the respective anion will be called as conjugate base. See, here it is releasing a proton now. So this is acid, 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 base. Acid after releasing proton, the respective anion is called? This base after accepting a proton called conjugate. Now go with the statements. Only fourth statement will be correct. See what they are saying, H2 is a conjugate acid they are saying. H2 is a base forming conjugate acid. So this is incorrect. Next go with this, H2 is a conjugate base. No, it is a conjugate. So they are saying conjugate base. HClO4 is a conjugate acid. No, it is normal acid. Okay, but only this one is perfect. Equilibrium constant means what we will write? Product concentration by reactant. So this ionic product of two ions that comes from water is called ionic product. What is that? Ionic product of water. Okay. So now if you measure concentration of H plus ion and OH minus ion at 25 degrees Celsius, at what temperature? It is found to be 10 power minus 7. How much? 10 power minus 7. This value is fixed. Okay. So now ionic product, how much it will become? Tell me. 10 power minus 7. See, H plus ion concentration is how much? OH minus also same now. Oh, see, oka water molecule dissociate అయినప్పుడు ఎన్ని H plus ions వస్తున్నాయి? ఒక H plus. How many OH minus? So both of them are equal means their concentration also same. So 10 power minus 7 into 10 power minus 7. So ionic product of water enta? 10 power minus 14. At what temperature? Why I am saying specifically mentioning the temperature? If I change the temperature, equilibrium constant value also changes. Andukosame this is at 25 degrees Celsius. So I will give you one more value. 10 power minus 6 into 10 power minus 6 equals 10 power minus 12. This is at 90 degrees Celsius. See, if I increase the temperature, what happens to Kw value? Minus 14 becoming minus 12 means what? Increased or decreased? Hedamma indulo pedda value. 10 power minus 12 is bigger value. So with increase in temperature, what happens to ionic product of water? So it means is this ionization of water is endothermic or exothermic? High temperature favors forward endothermic. So ionic product of water is an endothermic process. What is that? Endothermic process. Okay. Now if you take pH scale, so pH scale from where to where it lies? From 0 to 14. So in between we have 7. So why we are taking up to 14 only means what is ionic product of water we got? 10 power minus 14. So this 14 value here we are taking. Okay. So it means this scale is at what temperature? This is at 25 degrees Celsius. Now if I want to express pH scale at 90 degrees Celsius, what will be my maximum value here? 12. Okay. Now when I am saying 14, what is the neutral point I am saying? 7. So if I measure at 90 degrees? 6. So you should not say that on pH scale 7 means neutral all the case. No, it is not applicable. 7 means neutral only at 25 degrees Celsius. If I measure at 90 degrees Celsius, what is my neutral point? 6. Okay. So now question will be like this. 6 on pH scale 6 means acidic at all the cases. No. At at 25 degrees Celsius it might be acidic, but at 90 degrees Celsius it is neutral. Might be some 100-200 degrees Celsius it becomes basic also. Okay, it's a pH is a temperature dependent. What is it? pH is a temperature dependent. Temperature. Okay. Now how to calculate this pH? See, we have acids like strong acid and weak acids. So in case of strong acids, what is the pH formula we have? pH equals to minus log concentration of H plus. This should be expressed in normalities. Okay. So for example, I am giving 10 power minus 3 molar HCl. HCl is strong acid or weak acid? So now tell me what is its pH value here? Minus log. What is the, see, strong acid. Why I am saying strong acid? ఇది ఒకటి తీసుకున్నాం అనుకోండి, కంప్లీట్గా హెచ్ ప్లస్ అండ్ సిఎల్ మైనస్గా డిసోసియేట్ అవుతుందా అవదా? సో దీనికి ఎంతైతే కాన్సన్ట్రేషన్ ఉందో సేమ్ దాని హెచ్ ప్లస్ అయాన్ ఓహెచ్ మైనస్ సిఎల్ మైనస్ అయాన్ కాన్సన్ట్రేషన్ కూడా అంతే. సో వాట్ ఇస్ ద హెచ్ ప్లస్ అయాన్ కాన్సన్ట్రేషన్ ఐ షుడ్ టేక్ హియర్? 10 పవర్, ఇది ఎంత ఉందో అంతనే తీసుకోవాలి, 10 పవర్ minus 3. So pH becomes how much now? I hope you know these basic things like log a power b is there means b log a. Okay. Now what I can write here? 10 power minus 3 is there means minus already there. This is minus 3 log. So log 10 is 1. So I can write pH equals to minus of minus plus 3. So now I will tell you one simple trick. If concentration of H plus ion is given as 10 power minus x, 10 power minus x, 7. అరే pH 7 అంటే ఎంత? 25 degrees Celsius దగ్గర. మరి యాసిడ్ అంటున్నావు, న్యూట్రల్ అంటున్నావు, నీ ఇష్టమేనా? pH 7 means what is it? It should be neutral means it means 7 means neutral, but you are saying acid. So when concentration of H plus is equals to or less than or equals to 10 power minus 6, then consider concentration of H plus total as H plus ion from acid plus concentration of H plus ion from water. See, ఈ వాల్యూ పెద్దనా ఈ వాల్యూ? 10 power minus 6. So whenever the concentration of acid is less than or equal to 10 power minus 6, less than this value, in that case you need to consider total H plus ion concentration as concentration of acid plus concentration of H plus ion coming from water also. Then you will get the exact value. Okay, I will give one example, then you can get more clear. See, if I take like this, pH is 7, it is incorrect now? Yeah. So now what I should do here is, so pH formula, tell me once again, pH equals to minus log concentration of H plus ion in normalities. See, what I am giving you, I am giving a solution having 10 power minus 7 molar HCl. ఇప్పుడు ఈ solution అంటే this is a liquid, I mean HCl acid as well as water కూడా ఉన్నట్టే కదా? కదా? So what is the H plus ion from acid? 10 power minus 7. మరి ఇంకేమి ఇస్తున్నా మీకు? ఇది వాటర్ అన్నప్పుడు H plus ion coming from water also నా? What is the value from water? Ionic product of water అప్పుడు ఎంత తీసుకున్నాం? 25 degrees Celsius దగ్గర 10 power minus 25 degrees Celsius 10 power minus 7, 10 power minus 7. So what is the total H plus ion I should take? 10 power minus 7 plus 10 power minus 7. So it will be pH equals to now, this is 2 into 10 power minus 7. So minus log 2 into 10 power minus, అర్థమవుతుందా ఏం చేస్తున్నామో ఇక్కడ? Now simplify this. See, log a into b అంటే ఏం రాయాలి? log a plus log b. So it will be 7 minus log 2 వస్తుంది. So log 2 is 0.3. So 7 minus 0.3. How much it is? 6.7 around. Okay, is this clear everyone what we are doing? Clear or not? Yeah. Now one more question you do, then I will feel that it is clear for you. HCl concentration is 10 power minus 8 molar. Then its pH. Do it fast in a rough book. Okay, done? చేశారు ఎవరైనా? So pH equals to minus log. So pH equals to minus log concentration of H plus. So it is minus log concentration of, if I put like this, pH will be 8. Direct చేస్తే ఎంత వస్తుంది? ఇట్లా చేస్తే 8 వస్తుంది. 8 కరెక్టేనా? అప్పుడు ఏం చేయాలి? కాన్సన్ట్రేషన్ ఆఫ్ H ప్లస్ అయాన్ దట్ ఈస్ ఫ్రమ్ యాసిడ్ ప్లస్ కాన్సన్ట్రేషన్ ఆఫ్ H ప్లస్ అయాన్ ఫ్రమ్ ఓకే మైనస్ లాగ్ 10 పవర్ మైనస్ 8 ప్లస్ వాటర్ H ప్లస్ అయాన్ ఎంత? 7. సో టోటల్ ఎంత? See this one, can I write 10 power minus 8 as 0.1 into 10 power minus 7 రాయొచ్చా? ఇట్లా రాయొచ్చా? See 10 power minus 7 1 into 10 power minus 7 అని రాయొచ్చా? So add these two numbers, then it will be 1.1 into 10 power 7. Is this clear? దీన్ని ఎలా సింప్లిఫై చేశానో క్లియర్ అయిందా కాలేదా? ఓకే, నో ఇష్యూస్. 10 power minus 8 I can write it as 0.1 into 10 power minus 7. Is this clear up to here? 10 power 7 minus 7 ni 1 into 10 power minus 7 can I write? Yeah. So minus log, what is the number I can take common here? 10 power కామన్. ఇప్పుడు ఇక్కడ ఏం మిగిలింది? ఇక్కడ యాడ్ చేయండి. అదే చెప్పింది ఇప్పటిదాకా. 1.1 into 10 power minus 7. Okay. So now apply that log AB formula. ఇది ముందడికి వస్తే 7 minus log 1.1. So log 1.1 is 0.04. How much it is? Log 0.04. So 7 minus 0.04 ఎంత? 6.996 అంతే. So this is a pH. Is this clear everyone? How to do? Okay. Next ఇంకొక ఫార్ములా ఇస్తా చూడండి. pH of 2 into 10 power minus 3 molar HCl. They will ask you like this. What to do is, whenever H plus ion concentration is x into 10 power y, 10 power minus y. ఇగో ఇది ఈ ఫార్మాట్లో ఉందా లేదా? x అంటే 2, y అంటే 3 అట్లా ఉంది కదా. సో యూ టేక్ pH ఈజ్ ఈక్వల్స్ టు y మైనస్ log 3 log x. అంటే ఫస్ట్ వైన్ ముందర తీసుకున్నాం, తర్వాత మైనస్ లాగ్ ఆఫ్ దిస్ ఎక్స్, యూ విల్ గెట్ ద ఆన్సర్. ఇప్పుడు దీన్ని ఎట్లా చేస్తాం చెప్పండి? 3 మైనస్ లాగ్ 2. లాగ్ 2 is 0.3. సో 3 మైనస్ 0.3 2.7 69 అట్లా వస్తుంది, అదే ఆన్సర్. Clear everyone for this? Yeah. Now, you just answer me this one. Okay, pH of, please listen this last 2-3 questions. pH of 10 power minus 4 molar sulfuric acid. What is your answer? What is the answer? Fast. తప్పు ఆన్సర్ అని ఎక్స్పెక్ట్ చేస్తున్నా, అది కూడా చెప్పట్లేదు. 4. ఓకే 4 తప్పు, అదే ఎక్స్పెక్ట్ చేస్తున్నా నేను, కరెక్ట్ అయితే కాదు. ఓకే, సో వాట్ ఐ టోల్డ్ యూ, pH ఈక్వల్స్ టు మైనస్ లాగ్ కాన్సన్ట్రేషన్ ఆఫ్ H ప్లస్ అయాన్, దట్ షుడ్ బి ఎక్స్ప్రెస్డ్ ఇన్, ఇట్లా నార్మాలిటీస్ అని ఎన్ని పెడుతున్నా అప్పటి నుంచి, గమనిస్తున్నారా? బట్ హియర్ వాట్ ఐ హ్యావ్ గివెన్ హియర్, కన్వర్ట్ మొలారిటీ ఇంటూ నార్మాలిటీ, దెన్ యూ యూజ్ దిస్ ఫార్ములా. సో సల్ఫ్యూరిక్ యాసిడ్ ఎన్ ఫ్యాక్టర్ ఎంత, అప్పుడు నార్మాలిటీ మొలారిటీ వేరే అవుతాయిగా. సో వాట్ ఈస్ ద రిలేషన్ బిట్వీన్ నార్మాలిటీ అండ్ మొలారిటీ, m into n factor. So molarity is 10 power minus 4, for sulfuric acid n factor is 2, so it will be 2 into 10 power minus 4. This is the thing you need to use here. అర్థమైందా కాలేదా? అర్థం కాకపోతే మళ్ళీ చూడండి ఇక్కడ. సో pH equals to minus log 2 into 10 power minus 4. అప్పుడు ఏమొస్తుంది చెప్పండి, 4 minus log 2. 4 minus log 2. So it will be around 3.7. 699 something అట్లా వస్తుంది, 3.7 తీసుకోండి. అర్థమైందా? ఓకే, ఇప్పుడు ఇంకొక క్వశ్చన్, ఇవన్నీ రాసుకోండి తర్వాత క్లాస్ తర్వాత, ఇప్పుడు జస్ట్ వినండి. pH ఆఫ్ 10 power minus 3 molar NaOH. ఫాస్ట్ చెప్పండి. pH of 10 power minus 3 molar. See, is it base or acid? Base means, see, this is 7, this is 0, this is 14 at 25 degrees Celsius, I am saying. See, what is this region? Acidic. What is a strong acidic region? This is strong acidic, neutral. So it means if we move towards 7, it is weak acidic. So if I move towards 14, strong basic. So NaOH is strong base as acid base. It means pH value definitely greater than 7. But ఇప్పుడు మీరు ఇక్కడ అడిగితే ఏం చెప్తున్నారు అంటే అది కూడా తప్పనట్టుగా. See, when I give pH like this, don't do pH. It's a base now. Calculate POH. NaOH, how it will dissociate? Na plus. So which ion coming out? అప్పుడు ఈ కాన్సన్ట్రేషన్ ఎవరిది అన్నట్టు, మరి H ప్లస్ అయాన్ ఎట్లా తీసుకుంటున్నారు మీరు, తీసుకోవద్దుగా. సో యూ ఆర్ గోయింగ్ టు గెట్ OH మైనస్ అయాన్ కాన్సన్ట్రేషన్ ఇస్ 10 పవర్ మైనస్ 3. సో ఇఫ్ OH మైనస్ ఇస్ దట్ మచ్, POH అంటే ఎట్లా రాయాలి చెప్పండి, మైనస్ లా కాన్సన్ట్రేషన్ ఆఫ్ pH లాగానే POH కూడా. In the place of H we are writing OH, that's it. So POH equals to minus log of 10 power minus 3. అప్పుడు ఏమొస్తుంది, POH equals to 3. See, pH ఇక్కడ నుంచి ఇక్కడికి 7, ఇక్కడ నుంచి ఇక్కడికి 14 అంటున్నాం కదా. సో సమ్ ఆఫ్ pH ప్లస్ POH is equals to 14. ఎంత, pH plus POH equals to 14. Now how much POH we got? It means 14 minus POH if I do, 14 minus 3. So this is 11. So 11 అంటే ఏ రీజియన్, బేసిక్ రీజియన్ అసిడిక్ రీజియన్. సో ఇప్పుడు కరెక్ట్ వచ్చింది కదా, ఇట్లా చేయాలి ఎవరికి, నెక్స్ట్. డన్ ఎవ్రీవన్ క్లియర్ విత్ దిస్? మీరు right, today in the study hour also we have class. In the study hour also we have class. Otherwise ఈ సిలబస్ అయిపోదు. మళ్ళీ Done up to here? Okay, next. Listen here. When I say weak acid and strong acid, see, ఇప్పటిదాకా మనం డిస్కస్ చేసింది ఎవరి గురించి? Strong acids and strong bases గురించి. See, strong acid or strong base, if I say, that will 100% dissociate like this. That's why whatever the concentration of acid I am giving, that is applicable for H plus. So pH and em రాస్తున్నాం minus log concentration of H plus. If I say 10 power minus 3 for HCl, same value will be there for H plus also. But if I give you acetic acid, how it will dissociate? H plus. But is it 100% dissociation? No, only to some extent it is undergoing dissociation. So ఇప్పుడు మీరు డైరెక్ట్గా if I say 10 power minus 3 molar acetic acid, you should not say this is 10 power minus 3 directly. Why? Because it is 100% dissociation. ఎప్పుడైతే 100% dissociation ఉంటుందో you should indicate this arrow mark, full head arrow. But if it is partial dissociation like this, it is not equals to H plus ion concentration. So in this case, what to do? How can we calculate pH? This is a thing we need to study here. See, let us say I am saying acetic acid concentration is C, 0, 0 at the beginning. After some time t, what happens? Some amount of acid will get dissociate like this. So I should say C minus something. That something I am saying it as C alpha. So same amount will be formed here, C alpha. H plus ion also formed C alpha. Up to here clear? Okay. So it is dissociation now. You should say acid dissociation constant. Array, I can directly say pH equals to 1/2 pKa minus log C. ఈ ఫార్ములా ఇచ్చేసింది అనుకో నా పని అయిపోతుంది. బట్ ఇఫ్ అట్లీస్ట్ ఎవరికో ఒకరికైనా యూజ్ అవుతుందేమో అది అంత డెరివేషన్ చెప్తున్నా. లేకపోతే ఐ కెన్ గివ్ యూ ఏ క్వశ్చన్ లైక్ దిస్. ఫైండ్ pH ఆఫ్ 0.1 molar acetic acid solution. Given pKa is equals to 10 power, pKa equals to 4.74. Tell me, how can you do this? అయిపోయింది, డేటా ఉంది మనకి ఇక్కడ. pH equals to what is pKa? 1/2 pKa minus log 0.1. Next, half into 4.74. This 0.1 means 10 power minus 1 I can write. Minus 1 if I write here. So next, 5.74. Next, 2.87. Ante, అయిపోయింది. This is how you need to calculate pH of weak acid. Similarly, if I ask pH of weak base, don't find pH, there you find PYH. Same formula. ఇక్కడ వీక్ యాసిడ్ అన్నప్పుడేమో pKa వస్తుంది, వీక్ బేస్ అన్నప్పుడు ఇప్పుడు pKb ఫార్ములా చెప్పండి. హాఫ్ POH ఫార్ములా POH ఈక్వల్స్ టు హాఫ్ pKb మైనస్ C. సో ఇలా ఫైండ్ చేసి POH తర్వాత pH ప్లస్ POH రిలేషన్ ఉందిగా, యూజ్ దిస్ రిలేషన్ టు గెట్ ద ఆన్సర్. ఓకే, సో ఈ డెరివేషన్ ఎట్లా వచ్చింది సార్ అని అంటే ఇక్కడ వస్తుంది. జస్ట్ లిజన్, ఇట్ ఈస్ ఇంపార్టెంట్, దట్స్ వై ఐఎమ్ సేయింగ్. సో దిస్ ఇస్ డిసోసియేషన్ నా. వాట్ ఆర్ ద అయాన్స్ ఫార్మ్డ్ ఆఫ్టర్ డిసోసియేషన్? ఎసిటేట్ అయాన్ అండ్ H plus అయాన్. కింద ఏముంది? COOH. Now what is its concentrations given? C alpha, C alpha, C minus C alpha. అంటే ఒక C ని కామన్ తీసినాం అనుకో, 1 minus alpha. So Ka equals to C cancel. So C alpha square by 1 minus alpha. Okay. So this is what? 1 minus alpha, I am saying this is very less, which is equals to 1. So Ka becomes how much? C alpha square. So ఇందులో నుంచి alpha ఎంత అవుతుందమ్మా? Ka by C is equals to alpha square. Square if comes this side, root. So alpha value ఇక్కడ వచ్చింది కదా. See ఇప్పుడు H plus ion concentration ఎంత అన్నట్టు? C alpha. So C into alpha into Ka by C. pK minus log OH minus ante POH minus log A ante PA, like that. So I should say PA 1 by 2 pKa minus log C. So what is the formula for pH of a weak acid? Half into pKa minus log C. That's it. You remember this? Look at these two questions. That's it. Okay, next. See, you have enough number of questions in these slides itself. You can solve all these questions. These are more than enough for this chapter. Okay? All these are PYQs of NEET and JEE, EAPCET, all this. Okay. Next one is, what is this? This is a salt or acid or a base? Tell me. Salt. What type of salt? I mean, salt means it is made up, salt means it is made up of an acid or a base combination. For example, if I say NaCl, how it will be made up of? NaOH and similarly, if I give you this, what is the negative part here? So Cl minus. So you can take respective acid as HCl plus what is the NH4 OH, or you can simply say NH3 also for perfect. Okay. So now this is a salt. This is a salt formed from combination of a weak base and strong acid. It's a combination of what? Weak base and strong acid. This is ardhamaindi. Aithe I am giving you ammonium chloride salt solution. What I am giving you? Ammonium chloride salt solution. And I am asking you whether this salt solution is acidic or basic. Salt solution is now. I am asking whether this salt solution is acidic or basic. How can we say that? See, if the salt is formed from strong acid and strong base, you should say that as a neutral. What is this? Neutral salt solution. But if a salt solution is formed from strong electrolyte, it means strong acid here we use it now, so the salt solution will be acidic. Is this clear or not? Yeah. Now I am giving you one more, sodium acetate. How it is formed, tell me? From where it is formed? CH3COOH. So what is strong here? Which is strong here? So this salt solution will be basic. Yes or no? Up to here it is understood. Next one is salt solution యొక్క pH calculate చేయమన్నారు అనుకోండి. How to do? See, you are saying acidic now. So acidic means pH definitely less than 7 or greater than 7. So 7 minus, less than 7 now? 7 minus. Okay. So what is weak here? Weak base here we have. So for a weak base it will be pKb. For a weak acid it will be pKa. So you should say pH equals to acidic na 7 minus something. That minus something is 7 minus half into pKb plus log C. What is that? pKb plus log C. దీనికి ఏం రాయాలి? 7 plus half pKa plus log C. Perfect. Sir, you are saying that is two types of salt, but I have a salt now that is formed from both weak acid and weak base. Now tell me one example. Acetic acid, like acetate ion and ammonium ion. So from where this is formed? Acetic acid plus NH4 OH. So appudu itlantiదే kada. So in this case, how can you calculate pH? So in this case, see, when I have weak acid, I am using pKa. When I have weak base, I am using pKb. I have both weak acid and weak base, so I should use both pKa and pKb. So you can say this pH equals to 7 plus half pKa minus pKb. That's it. These are the three formulas to be noted. Okay, clear or not? Okay, let me show you one question on this. Wait. Read this question once. Time అయిపోయిందా కాలే కదా నెక్స్ట్ టెల్ మీ దిస్ వన్ which are the following salt only cationic hydrolysis is involved. The boys can go out.